As an instructor and a consultant, occasionally, it always amazes me how reluctant are people to do testing for the code that they write. And I don't know why they write code and they only try it with their devices and send it to the customer and ask the customer to try their code. It's like asking the customer, you go first. You take care of this, you tell me how it works and if it works fine, and I just want to know if there is any problem. Probably some of you would be thinking that it is not that important to do testing for small things, for small apps, because after all, what we are doing is just apps for mobile devices. They are not that important. Well, actually they are. But even the smallest things that we use require some testing sometimes. We want to be sure that these small things work perfectly before we use them. Also, we consider ourselves professionals. At least that's what I want to think of myself. And if we are professionals, we would like to compare ourselves with companies like NASA, like the presentation we had today for the keynote. I mean, like, they do a lot of testing. They were able to put this rover in Mars so precisely because they were doing a lot of testing before. They were doing unit testing. They were not doing the integration testing because, as she explained to us, it is not possible to test everything before sending the stuff to Mars. But at least they were trying to put all the pieces together to have them ready and tested before sending them to Mars, because it's expensive. It is also expensive for our companies to create software and to send them to customers without having tried that software before. So I would ask you to not consider yourself as an artist or a gardener who cannot test the results of their outcome, but to consider yourself a professional and try to prove that what you are doing is completely right. So today I'm going to talk to you about TDD and how to do TDD by controlling dependencies. And well, as I said, my name is Jorge Ortiz, and this is going to be a talk about how architecture helps us to do TDD. We will talk about TDD first, then how real life gets into TDD and spoils the results of our goodwill, and then how Swift helps us to have a better architecture that can be fully tested and help us to do TDD when we are developing for mobile devices and for OS X. So let's start with TDD. And because I don't want to be one of these people who starts talking about acronyms without explaining what TDD is, I know that probably everybody here knows what TDD is, but let me remind you that TDD is test-driven development. And this test-driven development means that we write the tests before we do any actual coding. That means that we know what we want to prove before we write the code. And well, that is very important because now we are changing the paradigm. I mean, instead of writing the code and trying to demonstrate that it works perfectly, what we do instead is create the tests that we know that this code will have to pass, and then we will write the code in order to make it work. I don't know how long all of you have been working in development, probably many years. For us, there has been a lot of progress, and we started with this sensation of typing something on a keyboard and writing a small program, and it does something, okay? That is kind of progress. But then we would change to the stage of being able to do what we wanted to. So our programs were not only doing something, but what we expected them to do. The next stage from that is testing. I can prove that the program does what I want it to do. But there's even more. You can go and do TDD. And then you can say, I'm going to say what this program is going to do, and it will prove that it's doing that because it's passing the tests. This is the path to nirvana. Okay? So once you have gone through all these steps, you get to a stage where you know that your code is doing everything that you were planning to because it's passing all the tests that you have planned in advance. How do you do that? How do you write the tests in order to make them pass and to fully cover the scope of your application? Well, the first thing that you have to keep in mind is that you only have to test your code. And that is something very important. If you're writing a core data application, probably you don't want, well, probably no. Surely you don't want to test that an execute fetch request, that is code that Apple has written for us, is working properly. You don't want that. It is Apple's business. It will work fine. You only want to write a test like that if you want to prove that they are doing something wrong. Okay? But that's not usually the case. Usually when you find a bug, like 99% out of 100, it is your fault. Let's assume that, okay? So here, what you want to do is just test the code that you're going to write. Only one level of abstraction, which means I'm going to focus on the top API, the level of API that I'm serving to other modules. So if this is a class, there is a public interface that is offering methods to other classes, and this is going to, these are the methods that I'm going to try, the methods that I'm going to develop tests for. Only the public methods. People usually think, oh, this method, this is very important. I want to know that it works properly. But this is private. So how do I try that? The thing that you have to do is to try the public method that uses that one. So you exercise that method, the private one. But you only have to focus on testing the public ones. If a method is private and you don't access to that, you don't have any access to that, it makes no point. It makes no sense to have that that test running for you. It even makes no sense to have the private method. So only public methods. One assertion per test. Well, that's not actually true. Assertion is what you expect the test to do. Sometimes you can have more than one, but the thing that you have to keep in mind is that if a test fails, it must fail because of just one reason. So you need a test failing, telling you that something is wrong, but just one thing. Because if a test is failing and is offering you a lot of things that it can go wrong, then it is harder for you to find out what was the problem in the first place. Finally, the test must be independent of sequence and state. If you run the tests in a different order, or if the test, the class that you're exercising, the class that you're testing has some previous state, you will have to inject that state in the test that needs to be run, not as a result of previous tests. Okay? These are general rules. I think that they are fairly easy to comply, but then it starts the TDD dance. And the TDD dance is what you do when you want to develop TDD. In TDD, you start by writing, as I said, the tests. So when you write a test, you have something that, well, it fails. I mean, it's red. Then the test, the code is written to pass the test, and then hopefully you get something that is green. The test has passed. Then you have the chance to improve your code. You can refactor. And refactor means that, refactor means that the code will be doing the same, and all of the tests should be still passing, but you can do changes to your code that are required or that help the readability of your code, that help the code to be more concise, that anything that fulfills your purpose. And you can refactor in order to have a method that avoids repetition, things like that. But every test has to be still passing after the stage of refactoring. What are the pros of doing TDD? Well, the pros are, the first pro is that you will have code that is 100% covered, which means that you have you have tests for every line of your code. If you don't get that when you're doing TDD, it's because you're cheating on yourself. You're saying, well, I don't need to test that. Then that's not covered. But if you do TDD properly and you refrain yourself from writing any line of code before having a test for that, everything will be covered. Because you are thinking about the tests, you are more sensitive to the edge cases. You're also more sensitive to things that you were not planning in advance. So what you have is the ability to detect scenarios that if you don't do the test before, you wouldn't notice. The progress that you do when you're doing TDDs can be measured. I mean, like, you know that you're doing some progress because you have more tests that are passing every time that you're writing. And it is easier to introduce changes because when you introduce a change, you know immediately how it affects to the rest of your code. Some people complain about how long it takes to write the tests. And I agree that it takes some time to do testing properly. But it is also true that since you are doing the testing beforehand, the time you spend on debugging is less. And that helps you on your productivity. It is also true that you are able to get a more decoupled code, explicit dependencies, single responsibility within the classes. You can do autopilot programming that it is essential for people that don't sleep much. I mean, you know that the code is working properly because you're writing the test and it is passing the test. Okay? Also, you get to a simpler design because one of the things that you try to do when you're doing testing is what is called as YAGNI. You ain't gonna need it. You don't put things in your program that are not required yet. So whatever you write in your program is something that is required instantly, and that's why you test it. The truth is that the things on the right side are not actually true always, but they are true most of the times, and at least they help you to have to get them easier. Okay? What are the cons? Well, the cons are people when they start thinking about TDD, the first time that you tell people about TDD, they think that this is putting the horse before the cart. I now have to think how to test something that I haven't even written yet. So, well, that is actually not true because when you want to go to a restaurant and you want to order, you don't know how the food is going to be or how full are you going to feel after eating the food. So You go through the menu and you ask for some dishes and you eat them and hopefully they pass the test. Okay? Another complaints are that it takes longer. But as I said before, it takes longer initially, but it is not true that it takes longer all the time because you have to take into account the time that you don't spend in the debugger, which I don't know about you, but for me, spending time in the debugger is tiring because, well, I mean, like sometimes it's, I run this again. Yes, the problem is there, but I don't know how to solve it. So I try again, again, and again, and I don't get to solve the problem. While when I'm writing the test, I know why it's not passing. Okay? There's an initial investment. I agree on that. I think that you have to do more stuff to get a basic case running. But, well, it pays off afterwards, and I think it's worth spending that time. Some people, and there was a very nice series of videos in YouTube with David Hennemeyer and Martin Fowler and Ken Beck. The title is TDD Dead? And it is a very nice series. And one of the points was if I'm doing TDD, I don't have the big picture in mind. So my design is not as good as it would be if I spend some time working on the design and then doing the development. But the truth is that there's nothing in TDD that tells you not to work in the design before starting with TDD. So I don't think that's an issue either. It is true. It is actually true that if the requirements change, the tests must be rewritten too. Not only the code, but the tests. And this takes longer. Also, it is true that you need more tests than unit tests. TDD is only about unit tests. And you probably will need integration tests. You will need any other kind of test like like performance testing. And here, you're only focusing on the unit testing. But that's not bad about TDD. I mean, that's something that you will have to do anyhow. Finally, people say, well, if I write TDD, my code is going to be better. Well, your code is going to be as good as your tests. I mean, if you write code that is not readable and your code is bad, your TDD tests are going to be bad. But that's not going to change how good your code is. So my point is that if you do TDD and you want to develop these applications that you're working on in the future in a TDD fashion, you will get to a final result by improving continuously the code that you write while you exercise the tests. Okay? But let's go into real life. Probably some of you, if not, how many of you have tried TDD? At least once. Well, okay, cool. So how many of you do TDD most of the time? Well, good. So what I'm saying is that yes, we try. Like this is going to be my next project. We're starting from scratch. I'm going to write the next class, and I'm going to write it using TDD. But then life gets in the middle of that, and you wanted to do the tests, but somebody's asking you to have the class ready. You have a deadline. It doesn't pass the first test. You don't know why, but it's not working. So, well, okay, let's forget about TDD, and let's do it as we did before. Well, some of the things that are tougher to tests are the UI, the visual part of your application. And people sometimes start trying to do the testing of the UI, and well, they think this is too tough. How do I emulate the touches? How do I know the information that is required to be tested there? Do I test whether the color is that or not? Do I test the font? Do I test the size of the view? What do I have to test there? We will discuss a little bit about that in a moment. Another thing that might be tough to test is persistence, at least our relation with persistence. Most of our applications are using some kind of data. That's a fact. But then, in order to try your business logic, you need to have some sets of data. You want to know that this data is going to be available and that the data fulfills the requirement to test that part of the logic. And then you start having small sets of data, and then you start having, well, what do I do? Do I leave the data there? Do I have two pieces of data, the one for production and the one that I'm using for the testing? It gets tough. So we will discuss a little bit about how to solve that. Finally, and this is for people who have been working with Swift or with other languages. How many of you have been using Swift 2, at least for fun? Cool. Okay. How many of you have used protocol extensions? Great. Okay. So protocol extensions are, in Scala, they are called traits, for those of you who have tried Scala too. And they provide the classes with additional functionality that can be complementary to the one that you have from inheritance without having all the thing that you get from inheritance. So it is an advantage. It provides with a cleaner design pattern for some stuff, and it avoids most of the multiple inheritance problems that you have in other languages. So traits are very cool. The problem is that traits are a protocol extension. And a protocol, as you already know, is something that doesn't have an instance. It is just a declaration of intentions. You tell, by using a protocol, what methods you are committing to implement. But you don't have any code for those methods yet. When you add a protocol extension for those, you're saying, well, this is a generic implementation, and I'm going to be able to use this generic implementation for these classes. You have restrictions in order to apply the protocol. But this code is not going to have any instance unless you apply this protocol to an actual class. So how do you test something that doesn't have any instance? We will discuss also about this one. So let's talk about TDD and Swift, and I put a small 2 there, is meaning that the one that I'm telling is not Swift square, Swift 2. So let's talk about how to do the testing of the UI. So, well, probably all of you know that Xcode was offering you the ability to write unit testing. Sorry, not unit testing, UI testing. I believe it was Xcode 5. Can anybody correct me on that? You were using JavaScript, now you can use Swift from Xcode 7 on. And, well, this is not unit testing. This is integration testing. Because what you are actually doing is you're running the whole application and you're trying to push that button, read that label, or swipe on that cell. That is completely different from unit testing. This is not wrong. I'm not saying that this cannot be good for your application. I'm just saying that this is not unit testing, and this doesn't help us to do TDD. Okay? So we have the same problem with other frameworks for testing. We Kif or Calabash or Cucumber are integration testing. So since TDD is about unit testing, about isolation of our module and testing that module isolated, how do we work with that? Well, if we use an architecture that decouples all of our logic, then it is easier for us to be able to work with the view in a separate way. So the view is going to be mostly passive, and it is only going to accept commands from the rest of our logic and provide the presenter with the events that happen on the view. And well, some of you might be thinking, well, another architecture. Well, this is not my architecture. This is not my idea, but this is the idea that comes from Uncle Bob's clean architecture that also is an improvement on other architectures like the onion architecture or the hexagonal one. So what all of these smart people have been thinking about is, well, we really have to focus on having single responsibilities. And having single responsibilities and a good way to communicate things is tough initially, but if you do this properly, it's very much easier to test. And if you have this view completely isolated and without any logic in it, it is very much easier to test. I don't want you to take my word for it. I want to show you some code of how to do that. So this is a UI table cell. It is a subclass of a UI table cell, as you can see here. And this is an actual cell. It is the one that I will be showing at the workshop in 2 days. As you can see here, you have 3 outlets. And the 3 outlets are for each of the 3 labels that are going to be presented in this table cell. I have 3 methods, and these 3 methods are implemented here, and they are declared in this protocol. That is the protocol that is going to be used by the presenter. So these methods are in order to change these 3 fields: the name, the title, and the date. And notice something that is very important here. The date, I could pass an NSDate, for example, which is the object that provides a date within Coco. But I'm not doing that because I don't want my view controller, my view, to be smart enough to translate the date into something that can be used in a view. I only want the view to display text or colors or things that are dumb enough, okay? So when I have that, it is very much easier to test that. I don't know how well this reads from back, but let me help you with this. I have a method here that is the one actually doing the testing, and what I do is I create a label that is based on this mock that I have written. This is Swift. You know that Swift is not as good as Objective-C in terms of dynamic dispatching. So all of the mocking libraries, mocking frameworks that we were used to and we love before, they cannot be used in Swift. But that is not a big issue because we can write our own mocks in our test cases. And this is what I'm doing here. I'm creating a label mock, which is a subclass of UI label. I'm overriding the text property. That is the one that is displayed when you have a label. And here, what I'm saying is, well, if this property is set, after it has been set, I want to set this flag to true. What I'm saying here is that I want to know if this property has been used, has been set. Okay? So that's very easy. Here, what I do is, okay, I want to use this label mock as the date label. Notice that this is the one that I was mentioning, that it has no intelligence to provide any formatting of the date, but it just displays the text that you provided with. What I do here is I use the method that I want to test, which is the display date submitted, and I use this, which is a constant that I have defined before. Here, then I have just to check whether the label has been used, the text has been set, and whether the value is the proper one. That's it. Very easy to test. And it works not only with the cells, but with the view controller. The table view controller can be tested. That's this. And the only requirement is that you define the proper protocols in order to abstract the communications between the different classes. The persistence. Same thing here. I mean, like, it is a requirement for the things that we do to have the persistence, to have the proper objects available for us there, but we don't actually need the objects to be persisted in order to be able to test that. So what we want is to provide an abstract class, a protocol, that will provide us with the data that we need at that moment in time for that test. So this is a little bit a more elaborated version of the architecture that I showed you before. This was the view that I was mentioning. That is not only the view, but the view controller also. This is the presenter. The responsibility of the presenter, as I said, is listening to the events that come from the view and doing all the presentation logic, as the name implies. The presentation logic can be something like the date is formatted like for Europeans or for Americans, which is different. Or it can be even something like the date is formatted in a relative way. So, for example, if you use any Twitter application, you sometimes prefer to have the date represented as 30 seconds ago or 2 days ago instead of at that moment in time. I prefer to know how long has passed since this tweet than having something presented to me as the actual date and time for that event. So here you have a presentation logic. You can change that behavior, and this logic will happen here in the presenter. The interactor is the logic, the business logic of our application. This is where the use case, the use story at least, happens. And this interactor is agnostic of the persistence that we use and the presentation that we are going to do with it. So it only takes care of the business logic of what we want to do. Then we have this repository pattern. This is a class that abstracts access to our data, and it can be using a web service connector, so I can be using an API from somewhere else, or it can be using local persistence here, or a combination of both, or I can be using a mashup of many web services. These will abstract the information that comes from there. Let's say that I want to be able to rent a bike if there is sun in some place. So I'm accessing an API for the bike renting service and another one for the weather service, so I can, I don't know how, mash up this information and send it to the user in a way that is useful to them. Okay? So what I will do in order to test my business logic, despite of the persistence, is to isolate this interactor, which I will do by having protocols that define the abstractions of these two layers. And this is how it's done. This is a very easy interactor, and this is in order to present a list of speakers. And what I'm having here is the name of the interactor. It has a relationship with the entity gateway, and it has another relationship with the presenter. And as you can see here, I only have an initializer that will take the data, the connection to the entity gateway, and this is the method that takes care of my business logic. What I do here is method says what it's going to do is show all the speakers, and it gets the entities from the entity gateway by fetching the data from this repository, and then it converts this data into something that can be used by the presenter, which is an abstraction. It's an abstract, it's a value that will be passed on to the presenter in order for it to modify it and tell the view what it has to do. Very easy. So how do I test that? Well, so there's not much that I have to do here. I can create an in-memory repository that has an object, and I can check whether this is passed on to the presenter properly. So I have a mock for the presenter, and then I will be checking whether this data matches the data that I have in this fake repository. Notice here that I ignore the case, and this is using a guard statement, ignore the case in which both lists, both arrays, don't have the same number of elements, because it makes no sense. I mean, if I have 3 speakers, I want to show 3 speakers to the final presenter. Very easy to test. I don't need anything related to core data or a web service. It is crazy to write a unit test that talks to a web service and provides you with the data from the web service and exercises that, because the delays of the web services, probably all of you have noticed that running tests in Swift, at least for me, it takes longer than it did for Objective-C, because, well, the compiling process is, can be better, okay? Then also, it is true that it takes a while, at least for me, to have this running into the simulator. Maybe my machine is getting old, but it's only 1.5 years old. So I don't know, but the thing is that this is not the case that we want to have something that goes to the network, brings the data, and we exercise this data into the application. So what we do want to have is an abstraction of this information that can be fed into this use case, and that we can test properly here. Finally, the testing of the traits. And I didn't want to have a protocol that you're not familiar with, and I didn't want to spend a lot of time explaining what a protocol extension could be. So I decided to use the one that is explained at the WWDC talk of this year. The talk is called Swift in Practice, and it allows you to have enumerations for the segues in your view controllers. I think it's a nice idea, and if you want an explanation of how this protocol station works, you can go and view this talk, which I think is a very nice one. So the implementation that I have here is straight from this talk, and is a protocol that it just defines this type alias. It's a segue identifier that it has to be row representable, which means that every case will have a row case, a row value, and these are the 2 methods that it's offering. The one is in order to perform a segue with an identifier by using one of these enum cases, and another one here is the segue identifier for this segue case, for this enum value, that will be used in order to have a switch that goes through the cases instead of the strings of the identifiers. So how do you test that? Well, it is quite easy. The things that you have to do here are to have a class that uses that code. And how do you do that? You do a mock. That is the class that you want to test that will implement that protocol here. So here, this is the mock class, and it's not only implemented UI view controller, which was one of the requirements of the protocol extension, sorry, but it is also implementing this protocol extension that I mentioned. So what I have here is these two identifiers for these two segues, fictitious ones, obviously, but I also have a method here that is overridden and that will be the one that records the call to this perform segue with identifier. You know the difference between mocks and stubs. A stub is something that tells you what you want to hear, and a mock is something that tells you what you want to hear and records what you said. Okay? So these are called nanny cams in States. I mean, like the ones that you have in a bear, that you have a nanny with the babies and you want to see what she's doing with the babies. So these nanny cams are closer to mocks. Okay? So this mock here is recording the parameters of the that have been used with this call, and what we do then is to check whether this perform segue with identifier invokes the classic version, so it talks to the actual method, and whether the parameters are the right ones. So it uses the first segue identifier in the first case and uses the second one in the second case. Very easy. Then I've been testing my protocol extension besides, despite it not being applied until it has a class. I don't need to have the actual class there. I don't have to try this protocol extension for every class that it is applied to. I instead test the protocol extension by itself, so the value of the results of these tests can be applied to every other view controller that I apply to this protocol extension to. So let me summarize, and then I will take as many questions as you wish. After all these tests that we have been talking about, the thing that you do is that you continuously improve the results of your application by writing a new test that covers more cases, more of your use case, and that takes you to a higher level. And all these tests can be applied to these different parts of the architecture. So if you have an architecture that is defined as the one that I showed to you, and that differentiates and that isolates each part of the application, each responsibility of your application, it is easier to write all those tests. Let me show you, because sometimes people, when you do something like that, and so this is a view controller. Yes, a view controller. And as you can see here, I don't know if you can read that. These are 92 tests, okay? But notice here that these are the tests for the app delegate. These are the tests for the in-memory repository here. This is a connector. I didn't talk about those yet. This is the protocol extension that I mentioned, the interactor, and also the classes that I use for displaying the data. So when I run this test suite, then I get a very nice message saying test succeeded, which means that every one of my 92 tests have passed, and that this view controller is fully tested. And don't take my word for that. You go here is it? Oh, yes, a second. This is to get the coverage data, and I have to run the tests again. And for this piece of code that I'm showing to you, this is the coverage of my class. Okay? So, well, not bad. You can do fully tests of your view controllers. You can fully test your persistence. You can fully test your business logic. Okay? So, let me go back to the presentation. Thank you very much. I would love to get questions, and I will try to answer them as well as I can. In any case, if you want to do any tweets afterwards, please include this hashtag so I can look for it and try to answer if you think of a question after the session. And please, please do rate this session. I would love to know what you think about what I told you. Thank you.
So we had some questions. Most important one first. Someone asks to come work for you. But any thoughts about BDD?
Well, not really. I mean, like the thoughts about BDD. BDD. Let's start with that. BDD is behavior-driven development. And one of the goals of BDD is to be able to express how the application should behave in terms of something that can be written most of the times in a way that even the user can express clearly. Most of the times I don't think this really works. I mean, like these domain-specific languages are not really that expressive for the common user. So we finally end doing something that is like, well, okay, you know that what the user wants, so you translate it to this language, and then we use that information in a way that can be used as the definition of the test. Nothing wrong with that, but I don't think that it helps that much. If you do want to do testing, I mean, like, I'm all for it. I mean, if BDD is your thing, go for it. I don't have anything against BDD. What I'm just saying is that I don't think that the common user, the business people, can use these languages to express what the application have to do. Any more questions? Are you testing like that? Do you get like 100% coverage? No? Would you love to? Really? Are you going to try? Who's coming to the workshop in 2 days? Great. Okay. So there we will be trying to do TDD, and we will be trying to do this improvement of the architecture in order to have these tests running. Sorry.
If you have a module that saves something in core data, you create an abstraction for that.
Mm-hmm.
How would you test that? Because then you would have to create the data in core data.
First thing is that, well, you actually can test the core data stack if you want to. I've been doing this for some time, and I think that is perfectly feasible. And what you don't actually have to do is to test the data itself. I mean, like, I don't think it's a good idea to test that the contents of the database are what you expect. It is not also a good idea to do the fetch of the data based on set that you have created and check that the fetch is properly done. Because as I said at the beginning, this is Apple's code, and you shouldn't test Apple's code. The thing that you could do instead is to be able to create some in-memory persistent store, which is very easily done. And what you do then is you create this stack as a fake one, the stack that you use for testing, and then each subclass of a managed object will be run within this new stack. This new stack will be an in-memory persistent store. It will share the mom. I don't remember the meaning of the letters. The manage object model is, yeah, thank you. So the manage object model will be shared by both stacks. The only actual difference will be that for the real one, you will be persisting the data in a file or in many, while in the data that you use for testing, the data is not going to be persisted because it will be created in memory. My recommendation is that you create this stack for each of the tests. So when you do the setup and the tear down of your test case, you create the stack, you run your test, then you destroy the stack. And again, it looks like a lot of work. It probably it takes longer than just a variable, but since it's happening in memory, it is very fast. So I have a lot of tests running core data, and I don't think that's an issue. You can really run them properly. But this, what I was saying is that this will have to happen at the persistence layer, while this is completely unrelated to what happens at the business logic, and completely unrelated to what happens at the presentation logic. You must be able to test each one of these layers separately. The requirements for writing a good, clean architecture is that the layers that you use have a dependency that can only go inwards. So in the outer layer of your code, you have things that you may be willing to change in the future. Like, for example, the UI or the database. If, let's say that now you want to change from core data to Realm or the other way around. Or you want to use plist because you have realized that you don't need that much power there. Same thing happens with the UI. And probably you say, oh, okay, I'm using the UI, the one that Apple provides me with for the mobile phone. Yeah, and now you want to address the Apple TV. And now you want to address the Watch OS. So if you have your views completely separated from your business logic, this is going to be very much easier. A lot, okay? Because your view layer can be even a different one for each of your targets. So your targets will be using a different view depending on whether you are addressing the watchOS or the Apple TV or the mobile phone. I'm all set? Okay, so did it solve your question? So thank you very much. Feel free to contact me and ask me.